To the June 2025 edition of the St. Louis Java Users Group. Next slide.
All right.
For those who don't know, the St. Louis Java Users Group is an informal group. We've been meeting since May of 1997. We're not the oldest jug around, but we're pretty old.
Whoa, you're pretty close up there. Yeah.
Attendance is free. We don't have any formal membership list. And normally we try to meet on the second Thursday of every month, except December. We don't have a meeting then because there's just too many things going on over the holidays for us to organize a meeting in December. For those who are in the training room, you can join us for food and social at 6 p.m. And we try to start the meeting at about 6:30 for those who are online and in the training room. This recording and live stream is originating from the Object Computing Incorporated training room. We're at 12,140 Woodcrest Executive Drive, Suite 310. And of course, that's in St. Louis, Missouri. Next slide. I'd like to introduce the other members of the St. Louis Java Users Group Steering Committee. So from left to right, we have Zach Klein, Ted Doyle, Robert Levitt, Wei Chi Gao, Bruce Olspaul, that's me yammering on. And you can email all of us on the steering committee at that email address at the bottom of your screen. That's javasigsc@googlegroups.com. Next slide.
That's how you know you're old, because you're using the interest group.
Yes,
yes. Like your JavaSig.
Yes. The Java Users Group would not be possible without the support of our sponsors. So from left to right, we have Object Computing Incorporated. They let us use the training room. They sponsor the Google Meet, which allows us to record this presentation and also to send out the live stream. And they've bailed us out so many times with pizza and everything else that I can't even begin to count how many times they've saved us. At the end of this meeting, we will be raffling 2 Manning ebooks and 2 JetBrains licenses, and they will be of your choice. But in order to win, you have to be present to win, either online or in person. So if you're watching this recording, I'm sorry, you're too late. You have to actually be here live. And I should mention, we are looking for additional sponsors so that you can just, if you know of a sponsor, please email the steering committee at that same email address, javasigsc@googlegroups.com. Okay, next slide. Manning has given us a 40% off discount code. So when you go through your checkout online, just put in that code there, or Chug 13, pretty much off anything, any product. Yeah. We're going to get some more information about this probably. But the Kansas City Developer Conference is coming up. They're kind of associated with our sister jug over in KC.
A little bit, yeah.
And I believe early bird tickets are still available until June 13th.
Yep,
so
tomorrow.
if you want more info, just go to that website there, kcdc.info. Anything more you want to say about that, Billy?
Yeah, so I'll go ahead and this way. Yeah. So one of the cool things about KCDC is we're a polyglot conference. So as you can see, we have tracks covering all number of different things. Of course, we have a full Java track. So every session we have at least one Java track or one Java session occurring, and we have a lot of great presenters. I was mentioning earlier, so actually next week, Venkat Subramanian will be our presenter, but we also have him for 2 sessions at KCDC. But you also have things covering things like virtual threads, instructive concurrency, stream gatherers, but then also, more current state stuff like how to improve your Apache Maven build. So yeah, definitely consider coming out. It's a really great time. Also, we have a testing and QA track as well. So yeah, a lot of great content. It's a really good opportunity because you get to meet people that you wouldn't normally get to meet, because a lot of times most other conferences, there's the one focus that just Java or just C# or something like that. So that's one of the nice things about KCDC is kind of bring everyone a little bit together.
Where is it located?
So downtown Kansas City, the Kansas City Convention Center. So which is like again right in downtown Kansas City.
Okay.
Yep.
All right.
Yep.
Okay. Next slide. UberConf is, oh, we have a question from
Yes.
the audience. Yes.
Can you get to KCDC from the Amtrak station without a car?
Yes.
Yes. Repeat the question.
Yeah. So someone asked, can you get to KCDC from the Amtrak station without a car? And the answer is yes. So you can just take the Amtrak to Union Station. And then we have our streetcar, which runs along Main Street, which is right next to Union Station. And that there would be a stop just a few blocks then from the streetcar to the conference center. So yeah, it's actually truly doable to like not need a car if you're here in St. Louis to go from here to there. So great question.
So that means I could get on at Jeff City and
Yeah.
ride the Amtrak in.
Yeah, absolutely. Yep.
For us Columbia folks. All right. Well, UberConf is coming up, and that's organized by Chase Zimmerman. He's the guy behind the No Fluff, Just Stuff conferences here, which he just had here back in April. He's going to have his conference July 15th through the 18th, 2025 in Westminster, at the Westin Westminster Hotel. And that'll be in Denver. And he's given us a $200 chug discount code. And there it is. So you might want to take a screenshot or point your camera there if you want that code. And if you want to use it and get more information about that conference, you can go to his website at uberconf.com. Okay, next slide. We have some presentations here scheduled. We've actually 3 months ahead, believe it or not. We've got, for our July meeting, July 10th, we'll have using MySQL document store with Java with another Oracle.
Yeah,
employee. How about that? Scott Strohs of Oracle will be presenting on that one. And then we have on August 14th, durable execution with Temporal. Tom Wheeler of Temporal will be coming in and showing us how to do that. And the September one is one I'm kind of excited about, and that's better understanding through bytecode. And this is Jason Clark, and he works for GitHub. So we're going to talk about basically how you program in assembly language for the JVM.
Not bad. Not bad. That's
What's really going down hardcore there. So you can actually get an idea of what you're compiling your Java into and what happens after that when you run it. Okay, next slide. So if you want to keep up with our presentation schedule when it changes, that's easy to do. Just go to our meetup site. That's meetup.com/gatewaychug. As we schedule presentations, we put them up on the meetup page. And so you can go ahead and RSVP for those meetings now if you'd like a reminder. This presentation is being recorded, and we upload the past presentations here to my YouTube channel. And that's at youtube.com/myname, well, @myname. If you'd like to give a presentation or sponsor the jug, you can just send an email again to the steering committee. That's javasigsc@googlegroups.com. So, next slide. Enough about me.
Yep.
Let's get to tonight's presentation on why developers should love testing. And I should mention and give Billy credit that he sponsored the Picklemans tonight.
Yep.
Thank you very much.
I'm sorry, I should have got a couple extra pizzas.
Yeah, it's hard to.
It's hard to
How
estimate.
many are actually going to show? All right, so why don't you take it away here, Billy?
All right, then. Let's see. There we go. Yep. Thank you, Bruce. Thank you for inviting me to come present tonight. As mentioned, my name is Billy Korando. I'm a Java developer advocate with Oracle, but don't hold that against me. There's plenty more else you can hold against me. And today I'm going to be covering why developers should love testing. And so like this presentation is a lot based upon like my experience in working from like several different organizations as a software engineer before making my switch now to be in the DevRel role. So like I'm not doing as much like, you know, programming and writing enterprise applications, enterprise level applications. But it's based upon because a lot of organizations struggle when it comes to keeping up to date. And I was kind of wondering why that is. And well, I think a big part of that is related to testing. And so some important information, please feel free at any point to ask questions. Again, Ted, if at any point someone online has a question, just feel free to stop me immediately and I'll be happy to try to answer it then. Yeah, I've given this presentation plenty of times. And also this is a very much more of a philosophical presentation, not necessarily getting too much into specific implementation concepts. So definitely it's much more prone to, having a conversation about it. If you have any questions, feel free to email me at billy.korando@oracle.com, and you can get to this presentation at this link as well. I thought I got rid of this, but yeah, no, doesn't matter. We had Java 1 back in March. It was actually really successful. I don't say this like there's times I was really worried about the level of success, but we should hopefully, we're intending to try to have it come back again next year as well, but information later. If you would like to know more, also we have a bunch of sites. We have our dev.java, insight.java, our YouTube, and our Inside Java podcast, which actually we're finally publishing podcasts again, which is really great. There's been a couple of really good ones that we just published over the last month. All right, so the agenda for this presentation, 4 major parts, why we write tests, a little bit on how we can write tests that we actually love, and then probably one of the most difficult things is writing reliable integration tests because, that's kind of like the death of automated testing suites is if you have flaky tests where you run it one time, it succeeds, you run it again, it fails, and there's no particular rhyme or reason to it, or you can know it, but then it's like, oh, okay, it's failing, now I have to go do this and stuff like that. So getting reliable integration tests or any is important, but particular integration tests is where it's often been more difficult. And then I'll get a little bit into additional tooling options. All right, so why should we write automated tests? So, a lot of times, like, I was talking earlier, like getting, like, there's a lot of like various principles like TDD, or like best practices to write tests and all that stuff. But like, there has to be more of a reason why we need to write automated tests because, like, let's make no joke, it takes substantial time and effort to initially write those tests. If you really have an advanced and mature automated test suite, you might actually even spend more time writing tests than the actual production code itself. And also, once you write all those tests, as you change and update code, well, you're going to have to update those tests. So that's going to be a substantial time and effort as well. And so all that time spent writing and maintaining those tests, well, that's time you can't spend writing production code, like actually doing whatever, implementing business logic that your business is asking, your organization is asking you to do. So like there has to be something beyond like, hey, it's best practices. That's just what we're supposed to be doing, or to say like Netflix does it, or Amazon, or whoever does it. Like there has to be some real grounded reasoning in how it's going to help an organization be more successful. And the bottom line is that if you really want to have like a truly automated deployment process, that is like I check in code and there is not going to be any sort of necessary manual intervention between you checking in code and going to production, that can only exist if you have an automated testing suite that verifies like, okay, Billy just committed code. Now, I always write perfect code, never written a bug in my life, and I never lie. But yeah, there's always that possibility where you make a change in one area and unexpectedly it causes a break or some other issue in something else. So like you need to have something there to test it. Now, back at a lot of organizations I was working at, that often went to the QA department. Like I would check in my code, like, I would do my own tests and whatever to make sure it was working, but then I would check it in and then we would have a bunch of actual, human QA testers that would go through and manually verify that like, yep, okay, all this code, this application is all working correctly. And like one of the places I worked at for a while, like a lot of our stuff was like wizard form applications where like people would step through like 4 or 5, 6 steps because like they're filling out applications for insurance licenses. And so like So yeah, I would check in my code, like, oh, okay, we need to make an update to the third page. Like we need to change like how long like a middle name field can be or something like that. And so like, QA tester would go and be like, okay, yep, now we can allow 30 characters in a middle name field or whatever it might be. And that, but maybe make a change there, but then you forgot to at the very end make sure you can verify or like it doesn't can actually submit that to the database or something. But yeah, you would have manual testing go through all that. But it's very easy to miss that. But yeah. But also I think one thing is again earlier on in my career, because like I was working on these like large monolithic enterprise applications, and because like that's was all the time I was spending on my job was like doing this all these changes to it. In my mind, I was kind of thinking like, oh, okay, like most of the code that's actually running in production is the code that I wrote. Like, it's like, oh yeah, like that's what's actually running in production. The reality, though, that it's just the tip of the iceberg. There's a code that you wrote, but then there's all the dependency code. How many people are using like on the Spring Boot or the Spring Framework? Like a lot of most people, yeah. And of course, everyone here, I'm guessing, is using Java. So like, you have your code that you wrote, but then you have your major framework dependency, whether it's Spring or Helidon. I guess I had to rep that, or Micronaut or Quarkus or whatever. That is there, and then they have like all their dependencies like Jackson or whatever it might be, and then under that you have the JVM or the JDK, and then under that is your operating system. So like that is where most of the code that is actually running. And this kind of gets back into where a lot of organizations I was at, like they had a lot of struggle when it comes to staying up to date for their underlying dependencies that, I always remember like, I mean, this is sort of dating me. It's like one organization I was at, like we were on Spring Boot like 1.2.5 or something like that. But like by this time, like we was like 1.4, 1.5 was the standard. And like it was also like 1.2.5, or whatever, and even for like that branch of it, like the actual up-to-date version was like 1.2 17, whatever it might have been at the time. And for a lot of organizations, like the reason that they wouldn't want to update is because it's like, okay, like, yeah, it's supposed to just be a patch version, but there's been times in their past where updating a patch version of some library ended up causing some sort of break in production. So it's just like, look, we know this code works. We're not going to change it. Like, let's just try to, not rock the ship too much or rock the boat too much. So we'll just kind of keep with it. But of course, that leaves you vulnerable to security, which is probably one of the major things. But then you also get to benefit from the additional performance benefits that you can maybe come from updating to a more recent version, or of course also all the feature things. It's like I remember there's been many times where those organizations like, oh wow, this is like a really cool feature, and then it's like, oh, I can't do that because we're all, several versions behind. And, that's kind of frustrating, obviously, as a developer to be like, my job could be so much easier if I could use this feature, but we can't. But really, again, a lot of the primary thing is just the security vulnerabilities that you could be being exposed to. So, but then, okay, it's like, okay, you want to update it, but then to do an update, because you're updating like this underlying dependency, you have no real true way of knowing like how it might affect your application. So if you're doing manual testing as your way of validating your applications, that means you would have to do like a whole regress test. And that can take a significant time and significant money. So like you wouldn't want to just be doing that all the time from an organizational perspective, because then your manual QA testers wouldn't have time to be testing anything else. They'll just be constantly testing it just to keep your your dependencies up to date. So that's where the automated deployment process comes in. But there's additional benefits. So I'm guessing most people have like somehow or like continuous deployment or the continuous delivery, like the CD and CI/CD. So like the guy who originally developed that, or at least there's two people. I'm forgetting the other guy, but one of them is Jez Humble. But definitely like look him up. He has some really great presentations on this. But I think like at a lot of organizations, they may hear like, oh, automate. It's like, well, we're not going to be able to get in. We're not going to really understand what's happening. It's like, you have this automated test suite, but we just don't know if anything's really being tested. But really, in the reality is, it's actually a much more transparent process than manual testing, because you can have your automated test suite and you can see all the areas of the code that's being tested, how it's actually being tested. Of course, you can do all the reportings from that. You can rerun that test. And again, this is kind of going from like previous experience where so much relying on manual testing, where it's just like, okay, like I made a change and then I deployed it to like one of our development instances, and then I tested it, but then I was accidentally testing in integration or some different environment. I wasn't like being malicious, like saying like, oh yeah, I tested it without, actually testing it. Like I thought I tested it, and I was just, in the wrong environment, and that led to some bugs in production. I think one of my most infamous bugs that I pushed to production was basically the friend of the governor of Rhode Island couldn't renew her insurance license, and apparently was pulling her hair out, and then called the governor of Rhode Island, who then called the chief executive of my company. And so that was a very long night the day after that happened for me. So, but yeah, we had like a quality automated testing suite, that might have been avoided. Maybe not. Obviously, your testing suite can only cover things that you kind of know about could be potential issues and obviously bugs and still get into production. But you substantially reduce that possibility. It creates a really nice safety net that if you do mess something up, it should hopefully catch it. But yeah, of course, it can then be repeatable. So you can re-execute a test to see if a problem persists or not. Hopefully, it's not because you have a flaky test, but it's going to actually catch it or something. And potentially on how you maybe write your automated test suite, you can maybe even run it against different versions of your code. It's like, okay, wait a second, this is failing all of a sudden. Okay, can we run it against, a previous version? Did that bug persist or not? A lot of times, at least a lot of places, or I know also how I often write tests, it's like all within like the same code. So like sometimes like you may not have that easy ability already to have it run against an older version. But if you did like have it as a separate repo, that would be pretty easy to do. Yes, Bruce.
You can do to try to identify, I guess I call it dependency count.
Uh-huh.
Because what'll happen is you'll write some code.
Yeah.
And it calls into library 1 and
Yeah.
library 2.
Mm-hmm.
But library 1 and library 2 depend on different versions of library 3. And those two different versions can come into conflict with each other.
Yeah.
And then what can happen is you're thinking, oh, I'm fixing a bug by upgrading to the latest thing.
Yeah.
That has a security patch in it. And then now that just interferes with the other one on the other side.
Yeah.
Causes breakage or no telling what.
Yeah. So Bruce was asking the question of like, what can you do to handle dependency hell? Which is where you just have a bunch of different dependencies, and you might end up in a case where you have multiple versions of the same dependency. That would be, I mean, I guess if you're using Maven, and Gradle has like the equivalent, just finding a dependency graph, because I ran into that issue one time as well, specifically with Jackson, where there was an area where we're directly calling Jackson at some point, like directly making references to Jackson. And I was just like, wait, why isn't it working? And it's because like it was making references to Jackson 1. Or like the 1x version, and but the real version that was actually often being used in production was a 2x version. And I was just like, oh my god, like because I was spending like an entire week on that, first finding out why isn't it working, and then another week on actually removing all those references and making it to where we're only using one version of Jackson. So yeah, I mean, that would just be more about doing a dependency graph. If you see you have that issue, seeing if you can get rid of it, because that obviously can be a huge pain to deal with. Yeah. So
The only other thing I can think of is to use like curated versions of all of these dependencies.
Yeah,
So you move, if you're a Spring Boot,
yeah, using their bomb. Yeah.
your Spring Boot in lockstep.
Mhm.
Something.
Yeah, no, that's a good point. Yeah, a lot of things like Spring Boot, like, and I think almost all the other major frameworks, like they have like their bombs, their build of materials, where that will kind of keep all that versions in sync, and to just try to rely on that as much as possible, not to have like a different version like manually written into your Maven or Gradle files, and then that way you kind of avoid that. Also, I guess just to say there is also a lot more tools out there now that can help you when it comes to like the upgrading, like this upgrading scripts, modern, from John Snyder, who we actually is from outside Columbia. Now he's down in Miami, but like he has like scripts that kind of help with like upgrading and with all your dependencies, and it would probably also help there with like, getting rid of potentially duplicate dependencies as well. So yeah, there's actually nowadays there's a few more tools as well for maybe helping to resolve that kind of issue.
Yeah, see, it would have been helpful if the Java module system understood the concept of a version.
Yeah,
It
yeah. I mean that the module system is a little bit that's a bit outside of scope when it comes to like the external library dependencies. It's more about exposing APIs between different parts of code. So yeah, but yeah. Dependency hell is well, it got that name for a reason. Um, so often a question becomes like, how many tests should you write? They can be very arbitrary. It's like, okay, you need to get at least to 90% test coverage on your code or something like that. But I think that's a fundamentally flawed way of kind of viewing it. It's whatever gives you confidence to deploy to production. So like we were talking earlier about like the performance benefits between JDK 17 and JDK 21. And I was like, well, in this case, it wasn't much one, but I was also equivocating because it kind of depends. Like if, I mean, I don't know, like, like if we made a change to like string concatenation, and if you're doing a lot of string concatenating, like maybe you got like a huge benefit doing that. Like most may not be doing that, but if you did do that, like you may get a lot of benefit. Like this also applies here. There's going to be some applications like your application that does like payment processing or is managing like the physical inventory or something. Like you're going to want to really make sure that that's correct. You don't want to charge someone extra or undercharge them or even like negative charge them, and you're outright sending money out. Like that's a big issue. So getting payment processing right is really important to any organization that's doing that. So obviously you're going to want to have much higher test coverage on that. But if you're doing some sort of like a batch process for sending out like a weekly newsletter or something like that, okay, maybe not everyone in your distribution list gets the newsletter, not ideal, but not also necessarily that 5 alarm production fire where you have to, you get that call at 2 a.m. that this needs to be fixed now. So that also reflects how much time and effort you should be spending when it comes to writing the automated tests for those various applications or the various parts within that application, that how important it is to the business, how much of a risk it is if something goes wrong. That should dictate also then how much time you should spend writing automated testing. And then also to the point when it comes to writing test coverage, like that number can be fudged. Like if you can get to an arbitrary, percentage of coverage by not really, actually, like you can say like, yeah, we're having some sort of test that is going through and checking this, but if you're not really doing much when it comes to the assert to make sure that it's correct, that's not giving you much. Also, I'll get a little bit later where you could also somewhat similar. You could be thinking like you're writing and asserting correctly, but you maybe aren't. There's also tools that kind of let you know about the quality of the test you're doing as well. But yeah, so yeah, like I said, I think the way is like whatever, but basically is as kind of pretty, whatever gives you confidence to go to production without some sort of manual intervention before that. And by that, I mean having some sort of QA person or someone say like, okay, is this code or is this correct? Yes.
So are you mostly talking about unit tests at this point?
Anything like I said, the goal, at least my goal in this presentation is that when it comes to establishing the correctness of your application, you should be relying entirely on automated testing. Now, there's still a role there for manual testing, but that's like exploratory. But yeah,
Yeah. With this question.
no, like so, not just unit testing, but like even integration testing, like whatever gives you that confidence to go to production between that your automated test rate's like, yep, check code in, automated test rate ran, it's green, go to production. Like we know there's no, I mean, maybe you might be like, we only do it at midnight or whatever, but go. Sorry.
Did you start your talk with the almost quintessential test pyramid, right?
Yeah. Yeah. Cause
Through that.
Mhm.
And you said test coverage a number of times. And for me, coverage, especially with code coverage,
Mhm.
becomes irrelevant once you move up all the unit tests.
Yeah, exactly.
Issue tests,
Mhm.
end-to-end tests.
Yeah.
All those tests rely on scenarios,
Mhm.
which ought to be part of the business's acceptance of the software.
Yeah.
And to answer that question, what are the critical scenarios that have to succeed?
Exactly. I mean, exactly. That's why I think something like test coverage is a kind of an irrelevant thing. And it's also some things like unit test coverage, like, it may be testing your code, but like in often things like security testing is like, it's usually not quite, it's like a different level from your code. So like, that's not even really exposed in test coverage. And like, you could be like at 90% and then not be testing any of your security stuff at all, which obviously could be a potential huge issue. So yeah, that's kind of why. And why I also say it's like whatever gives you that confidence, because this is going to vary from business to business and from specific applications or specific things to where it's like, yeah, but whatever gives you that confidence between integration testing, end-to-end testing, API testing to go to production, then that's good. Don't write any more tests. If it's like, yep, you're confident, don't add a test unless you're obviously adding something. And don't take away unless you don't think it's
So,
yeah, no, go ahead, please.
we went forward an argument, disagreement over the product that went some years back.
Uh-huh.
Who asked me, what is our code coverage for our acceptance tests,
Mhm.
functional tests at the API level? And I told them there's really no correlation.
Yeah.
The level, the amount of code you're covering on your functional test is irrelevant. The question is whether you're actually capturing the scenarios of those functional tests.
Yeah. Yeah.
Besides, Mr. Product Owner, you're going to tell me, well, what are the business scenarios that have to succeed or have to fail in certain ways?
Mhm.
My job is to make sure the software does that.
Yeah.
And then what is your coverage is dependent on how many scenarios you define.
Yeah.
So if you find 10 scenarios and you need all 10 of them, it's probably to succeed. You want 100%, all 10 of them.
Yeah.
If you find 100 scenarios, there's going to be 100 tests that get succeed. So
Mm.
it's really nothing to do with that level of code. So.
Yeah, exactly. So sorry, just for everyone.
What are the functional coverage? Same way functions and the cover. That would be the fallacy of 100% code coverage, which is that, of course, just because you execute every line of code doesn't mean that you have A, good test, or B, that it's expected to do.
Yeah. Yeah.
Functional testing and code testing. No, it's not a reality.
Mhm.
You could get list your functions and you test those. Correct. That means like feature testing. Other way thinking.
Yeah.
Absolutely.
Yeah.
100% on series that defines script.
So sorry to also just everyone online, just to kind of go over at least a little bit of this line of discussion. So someone is kind of asking or kind of brought up how like there's like the quintessential test pyramid where you have like unit tests and then integration tests and then functional testing. And like, yeah, like that it's just a wrong way of thinking about it because maybe unit testing doesn't make a whole lot of sense. And like to what you were just saying as well from like a previous experience where you just needed to work with like the business person on developing functional tests and they just needed to tell you what was correct. And again, this is kind of why I get back to it's like how many tests should I write? it's just going to vary. There is no standard. There's no like, okay, if you're writing 1,000 lines of code, then you need to have n number of functional tests, or you need to hit this specific point. Because then you start to get to a specific point rather than really thinking through, does this make sense in this scenario? Like there can be smells like, yeah, if you have 10% test coverage, it's hard to say that you are going to be confident going to production with it. But maybe 50% actually is enough for some scenarios or something like that. Again, it might be a very low priority thing that isn't doing much to where if it completely fails, the actual bad scenario isn't too bad. But yeah, when it comes to manual testing, this isn't. Oh yes, one other question.
What Jen said.
Uh-huh.
What are some ways you could choose or design your stacker architecture to make it easier to shift left?
Sorry?
To make it easier to shift left. So to automate testing.
To automate testing. So yeah, the question is, how can you make your code more easy to test? Probably one of the better ones would be following like solid design principles. Like that would be, oh, it's been so long, like Singleton, like particularly single responsibility, open, close, the list cost. Yeah. Probably like the substitution one could be one of the more important ones, where you can replace an underlying thing with a test implementation to like test up a code. I'll kind of get a little bit back into that when it comes to mocking, like dependency injection, and all that stuff. And yeah, so I think following those principles, if you're writing that like in your code, in almost all cases, or in the vast majority of cases, should be reasonably testable without it being too difficult. If you write a mud bowl, which was some of the applications I was working on early in my career, where it becomes almost impossible to effectively test, or at least almost impossible to do any unit testing on it, because I mean, there's like applications where I was writing that had like a method that was over 1,000 lines long, where you're like writing to the database, making a call to an external server, and like it's impossible to really isolate and test it. So yeah, following good solid programming principles is good. Yes.
Talking about this, I'm sure, but I would add to that, writing tests about the same time as you're writing the code. Maybe
Yeah.
before.
Yeah. So like a good way is doing something like test-driven development. I've never been a great adherer to it, just because like my way of developing, it's like I had to think so much before of like, okay, like how do I really want to attempt to do this? And at least for me, having to first think about like all those tests has made it difficult. And then sometimes it felt like it would lock me into an implementation. Now that's just me. I'm not suggesting that TDD is wrong. Like if you like TDD, go for it. But at least for me, it was always a bit more. It's just like it just didn't help. Like it's fine in like a little simple, contrived like proof of concept, but like at least when it came to like real world scenarios for me, it was very difficult. Um, yeah.
Tool of TDD
Hmm.
you're using.
Yeah.
Secondarily, TDD is both a test practice and a design practice. So
Yeah.
address something you just said.
Yeah.
How do I think about this? You're always thinking about the code from the perspective of using it as a client.
Yeah.
And then I've also been pushing for quite a while practices around acceptance TDD.
Yeah.
From a story perspective, says, tell me what it takes for any implementation of the story
Hmm.
to be acceptable. Give me the scenarios, and then I will write tests at some level of the architecture.
Yeah.
That bodies of scenarios to show we're actually doing we're guessing the story.
Yeah.
In all those levels, it has some benefit. And the primary benefit to me, why I said it, is because code that isn't written testable is fundamentally not testable.
Yeah.
It rarely until level of exposure what you want will determine whether it did the job that it's supposed to do.
Mhm.
It couples things together in ways that make it almost impossible sometimes without significant being intense.
Yeah.
And you're always focusing on the mechanics of things as opposed to what is the code we're trying to accomplish.
Yeah. Yeah, absolutely. To what the audience member was saying is just that, there's different schools of thought when it comes to TDD. There's also higher levels like acceptance TD, which I think that could be good. I mean, sometimes it can be difficult to have organizations that have that level of maturity that actually know how to like write reasonable acceptance tests. At least, again, this is my experience is that a lot of organizations just didn't quite have the maturity to actually like write that, or they didn't even quite know. It's like I wanted to do this in a very nebulous way, and then then you have to kind of start to figure that out. So like a lot of it also depends upon having organizations that kind of have that maturity on the business side that can kind of provide somewhat concrete, acceptance criteria that can then be actually in a real way coded to. But yeah, I think at that level, I think that could be very helpful again if the organization does have that maturity level. Yes.
How do you test that the documentation is in sync with the code?
So the question was, is how do you test that the documentation is in sync with the code? Well, I mean, there's a lot of different ways. So I think at the most ideal level, and I'll get to this a little bit later when it comes to writing tests you love, is that the tests themselves could be written in such a way that it could be the documentation, at least at some pretty reasonable level. I mean, there might still be more human readable, higher level documentation, but there are a lot of good test frameworks that JAssert or Assert J, where you can really write it out to where it's very human readable to read it. So ideally, I think like you can write it to where your tests themselves could be to some real extent the documentation of it, and then that way you can kind of keep them in sync. And there's also other things like behavior driven development where it's even like the given, then, when, where again that's also pretty human readable. Again, at least my experience, sometimes it's kind of hard to work with like a business people to have that ability to actually write that stuff in a way that's you know actually programmable against. But if you are able to get to that maturity level in your organization, then that is also the way, because your documentation is what's testing it. That helps a lot.
I'm thinking in terms of the Java doc.
Oh, the job.
Java doc may say your method does one thing, but it's doing something else.
So at least one other way that it can be at least a little bit better, and this comes, I can't remember if going by LTS versions, if it was 17 or 21, but we added a way to where you could actually reference the specific. So like before you would, if you wanted to say like, oh, what this code is doing within like the Java doc itself, sometimes you would do that. Be like, what this variable blah 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 is doing. You would actually have to write that all out, and then to your point, like the code could get out of context. We added the ability to be like, oh, reference lines, X to Y within your code and put it in here. And then that way it would always be in sync within the Java doc if you're referencing like a code example. But as far as saying like, get first name and then like you change it to be get middle name, but the Java doc in there is saying like gets the middle name or first name. I mean, I mean, at some point it does require like a developer to actually like know and care.
Documentation, they don't put in the
Yeah.
contract.
Yeah.
The first thing that I do, generally when I hear something, is I go through and I get rid of all the Java doc on the other sectors.
Yeah, exactly. That, yeah. And then also it's like, try to write your code in such a way that it's reasonably self-explanatory. I think, you can't always entirely do that. Because like sometimes you need a broader context, but don't, and that gets to your point of you don't need Java doc for getters and setters or constructors. Yeah, you're just, it's just corrupt. It's again, I mean, again, a little bit to like the principle of this, uh, write stuff that actually makes sense and not just follow some sort of cargo cult, like you need to document every method. That's kind of some of the principle this is coming back to. Putting Javadoc on every single method or every single class doesn't make much sense if it's like a simple POJO. The person POJO, you don't necessarily need Javadoc around that unless there is a reason for it.
And
Yes.
handling the error conditions because, we can talk about the happy path.
Yeah, I mean, you have to test both. Yeah.
When something goes wrong.
Mhm.
So you'll call some method and say, if this thing goes wrong, the exception that gets thrown is going to be this one.
Yeah.
If something else went wrong, this is the exception that's going to be thrown, so that your exceptions are actually informative and tracking down what happened.
Yeah, absolutely. Yeah, yeah. It's obviously important that you don't want to just,
To test those error
yeah,
situations that
and that
the exceptions do happen.
yeah, exactly. And again, that's stuff that doesn't always show up in unit test coverage either. So that's our code coverage. So yeah, it's important. Like that, and that's again why I get back to this, because like there could be an exception that never happens. Like you need to handle it because for some reason, Java or your underlying library is saying like this exception could be thrown. You need to handle it, but like functionally, it should never happen. Or if it does happen, it's like, oh, well, your database password is now misconfigured. Like, that then you don't really necessarily need to test that scenario. That's going to be quite obvious that you need to update your password, and you don't really care if your method that's looking up a person's address can't handle the password or the authorization exception properly. You had a question, or did
Like a really bad joke.
okay, no, but that's already passed. Yeah, I get those or I do that all the time also. Yeah, moving on. So yeah, when I'm talking about automated testing, but this isn't me bashing the concept of manual testing. Manual testing is still important, but it should be more exploratory, and it should be something that's kind of happening in parallel with like software development. So you should just have QA people out there testing to make sure that your automated test suite is actually covering all the different scenarios, because it can be very easy that unwittingly someone adds something and didn't think to cover all the different test scenarios, and it might be important. So yeah, you would have that happening kind of in parallel. Not that I consider them best person, but like there's the Donald Rumsfeld, the known knowns, the known unknowns, and the unknown unknowns. The exploratory testing would be about particularly the unknown unknowns. Okay, so this kind of maybe a little bit gets to what conversation we were getting back before, is how can I write tests I love? So for one thing is, I remember again, this is just very much kind of based upon personal experience. When I first started doing automated testing or writing tests, it was just like, oh, it's test code. Who cares? Like it doesn't really matter. So like I was just doing a lot of Control C, Control V, not really caring how the code works. And yeah, that becomes very difficult to maintain. So treat test codes with the same care as you would treat production code. So a lot of the times we go and refactor our production code because like, oh yeah, we're kind of having the same thing happening in 3 different areas when it could be refactored into a single area. Yeah, just treat it with the same concern that you would treat with production code. But maybe in one area where you might be a little bit different, highly prioritize readability. And that's what's continuing to with like things like assert J, which I'll touch on a little bit later, but try to make your code as readable possible so it can actually kind of really act like documentation code. Because like sometimes when you're writing production code, like if you have like a for loop or something, you want to just use like I or X or something as like the iterator. You don't necessarily want to write that out, but maybe within like a test, you might be being like number of records returned within it or something like that. And of course, refactor test as needed. And of course, also start if a test is providing little or no value, get rid of it, because obviously you don't want to be like, oh, we updated it, this test failed, but this test doesn't really mean anything. You don't want to be forcing yourself to spend time maintaining a test that you don't care if it succeeds or fails. So at which point, just remove it or refactor it to where it's easier to maintain or update as needed. Well, this is actually very dated, but that if you're How many people are on JUnit 4 or before still? Like, well, I mean, that's separate. That's separate tool, but yeah. So I think pretty much everyone, because like JDK 8 is now the accepted minimum of the Java version. But yeah, so a little bit of history about me. Like one of the ways I kind of got started with speaking, or building this a profile was actually when JUnit 5 kind of came out and back in like 2016, 2017. And it just so happened like no one else in the United States was talking about it. So I got accepted to a lot of conferences that I probably wouldn't have otherwise got accepted to. But all the same, if for some reason you're still not on JUnit 5, definitely upgrade. But it's a substantial improvement if you've gone from JUnit 4 to JUnit 5 over the difference. But there's a lot of things, parallel tests, repeated tests, extensions. Definitely the extensions is really nice for writing in a lot of like stuff that makes sense for your organization. Selective disabling is also really good if for some reason like your developers on Windows machines, but you're working on Linux or like you're deploying to Linux that like, like file handlers are obviously different. So if you can be good to be like, disable these tests when they're on Windows, but then, actually have them running in your build server. So a whole lot of benefits in there. But now by now, this is all very old. Also use assertion libraries. So still, I think the most two prominent are AssertJ and Hamcrest. Are there any others? Really? For as far as assertion libraries, I don't think so. But all the same, whichever you yeah.
See assert keywords still.
We do use it like internally. So Bruce asked us, everyone uses the assert keyword. We do use it internally within the JDK team some, but not too much because I think it was meant there for like testing purposes, but it was never really quite supported properly for that. Occasionally there's discussions around it that like I don't follow it too closely other than I know it's like, oh, there's Brian talking with another JDK person about Brian Getz talking with like about the assert thing or, some of the things like, oh, we should have done that a little bit differently. So I can't really remember that too much, but also it's just not that expressive. It's like, it's just like assert whatever. But yeah, use whatever assertion libraries that kind of makes sense. If you really like AssertJ, use it. If you use like Handcrest, use it. Like the default assertions for like JUnit aren't super great. I remember again when I first got into automated testing, like for a long time, like it made sense to me that the assert equals like to have like my expected value and then followed by the actual value followed by the expected value, but it's expected value followed by actual. Yeah, whichever way. Like, but there's no correct way other than there's no like externally objective correct way of what it should be other than obviously the way you did it. But part of the reason why the JUnit team didn't spend any time on changing that or updating it is because it's very easy to plug in external assertion libraries. Yeah.
Isn't necessarily always isn't always correct, right? But it's
Yeah.
a convention that's better to follow. For example, I did some like research in linguistics, and I read somewhere that most languages tend to be subject verb object order, like
Yeah.
subject object verb like Japanese or whatever Irish
Mhm.
is. So isn't it?
Yeah.
Convention that's a little more intuitive, then shouldn't we try to roll into that convention? For example, I think for assertion statements, it makes more sense to put the expected result first and then compare the result and then the actual result.
So the question is, and this again is very much if you're using the built-in assert equals within a library, and there is no there's no truly objective way of being right independent other than however the actual, but that's also why our assertion libraries are better because it's like AssertJ, if you want to do equals, you'd be assert that whatever value is equal to, then it becomes clear, I guess if you're reading English and everything, like it becomes explicitly clear what is actually being compared and how, versus again, it's always a bit vague potentially when it comes to how it's written directly with assert equals in Jane. Like I said, and for a long time I was doing it backwards, and then I'm like, oh, that's why it's so difficult to understand what's going on, is because I had it backwards, and if I did it this, then it's a lot easier. So yeah, quite
Before,
okay.
much like in-fix versus post-fix notation. CI speak of it.
PI 83 all the way.
It's just about whatever community developers is that I'm working.
Yeah.
Standardized it. Most areas on hand press.
Yeah.
But the Spectrum, which is part of the same big organization, they didn't have it. So they're still, I'm not sure they're standardized on anything actually.
Yeah.
So, I think for me, it's completely comfortable with whatever team is something.
Yeah.
It's community decision.
Yeah, I agree. So yeah, the question is like what to choose what, and sometimes you just have to adopt to whatever the consensus is as at your organization, or if there's like none, try to find one maybe perhaps. So yeah.
What's the strategy as far as checking preconditions, post conditions, and the invariants on your classes? I mean, what I've seen is the convention that seems to be followed is when you're writing a class, they're not talking about the separate JUnit code.
Yeah.
On entry, you write precondition tests to make sure that your input values make sense and things like that.
Yeah.
And then right before you return, make sure the post condition is right in there, and you need to have some code in there to check the class invariants. So the state of your class is never getting into some illegal state or something like that. That tends to be, if it's a public method.
Yeah.
You won't use the assert keyword. You'll actually write out this because there's a dash EA that enables assertions, and in production, you're not going to run with assertions enabled.
Yeah.
You're going to be enable your assertions when you're testing. But if it's a private method or something, on entry, you should be using assert keyword there, because supposedly then, once you're in production, it will have been checked before you call that private method or something.
Yeah.
I don't know what the thinking is.
Yeah, I think that's a little bit tangential to like automated testing, because like that is about like you deploy to production and like you're reading in files from like a property file in production and then making sure that they make sense or something, and it's sort of automated testing, but it's a little bit outside of that, and I haven't done too much in that area. I feel like also, I guess if you're depending on that kind of asserting, like I don't know, I feel like that could always be a little bit better with some other ways of verifying like your production property files are done before you even get to production or whatever it might be, so where you're not relying upon something that's like at startup to make sure everything's correct. So
things like validating the input before you feed it in.
yeah, exactly. Yeah, or even like validating it within like your build pipeline or some other tool that kind of makes sure that that's all correct before again even gets out into production. So okay, so yeah. So then also, for any automated test suite, it's really important that you have reliable tests. You don't want, so again, this, I think by now, or you probably just saw, so I'm going to be talking about test containers, but like one thing that was really difficult is like, virtually every application, anything beyond a trivial, like Hello World or tic-tac-toe application, you're going to be depending upon some sort of external dependencies, database or some other external service or whatever it might be. And it can be really then difficult. Like, how do you test that? Because like if you're depending upon this external service, you could be testing something that asserts that's working with it, but like it could fail because like that service, like QA instance could be down, or the data has been changed, or any of these number of things could change about it. That could cause it to fail, but it has nothing to do with the correctness of the code that you're working on. So writing reliable tests to where if something fails, that means something's wrong and you need to fix it within your code is really important. And luckily that's a lot easier now with tools like test containers, because before for like database testing, you would use something like H2, which is like an in-memory database, would try to simulate, like, oh, okay, I'm working with an Oracle database, it's simulating that, or working with a MySQL, Postgres, whatever it is. And it could do like a reasonably good job. Like you could do it like 90% well, but that remaining 10% ends up being really important when it comes to production, because maybe you have like some sort of procedural code within your Oracle database that's, doing whatever. And, like H2 can never really effectively simulate that. But a tool like test containers, has everyone heard of test containers before? Or yeah.
We've had talks.
Nice. Yeah. So if you're not familiar with it, but a few people will raise their hand, test containers is a tool now, actually not too new anymore, where it could actually spin up a container within the life cycle of a test. Like initially it was only at the individual method level. Now it's actually up to different class or even across the application level. But yeah, then that way, if like you're working with Postgres in production, you can actually spin up an instance of Postgres to the specific version that you're using, and then test against it. And maybe if your organization is really mature, like you actually have like your database team, creating instances or updating container images of like your database, and you can just actually pull that down and then test against it. Obviously, you would need to use different data. You have like some sort of test volume instance that could load that data in to test it against. But that is a way that, your test can be very reliable. Maybe occasionally needing to do updates to get like your test data back up to date because, the year changed and now you need to do something like that. But that way, you're not running into issues like, oh, the QA database is down. That's why all these tests are failing. Or someone went through and changed a bunch of test data and now that's why everything's failing. Like if a test fails, it's because, something was wrong in your code and you need to fix it. And then again, like this gives you the confidence because you have flaky tests that's like, okay, a bunch of the stuff is failing and it's not because of anything we did wrong. Then you start to ignore it. And eventually you're back to like where you're having to do a bunch of manual testing and all that stuff. And that fails it. So yeah, exactly. But I just kind of went through this, the points. So someone brought up Aikido. So to the point of holy wars, I think there has been, I don't know the current state of it. I hasn't been following as closely, but for a while there was just like, like, oh, do mocking. And then it's like, no, mocking is absolutely the worst thing in the whole entire world. If you do mocking, like you're not actually testing anything. My personal opinion, mocking can be fine, but you need to really understand what you're trying to do. Because I think a lot of times the issue people do with mocking is like they're really trying to simulate the underlying business behavior in the mock, when what you're really trying to do is testing how your code reacts to whatever that mock is doing. So mocking can be very good for trying to handle like those obscure error conditions. So like what happens if you get like there's to never be a null value that's returned from your database, but like sometimes that can happen. So like instead of like trying to like set it up in your test data to have like a null that comes back, you can just have your mock set up to say like, okay, this is return like a whole null value. Can your code handle that without exploding? Or can your code handle it when whatever this other weird condition happens, instead of having to really spend a bunch of time trying to like set up a scenario to where that could happen. You can just write a mock just to make sure that like your code can actually properly handle that. But yeah, it's just important to kind of, to the point earlier of like how to write testable code, to the like of solid code, the Liskos substitution principle, to where it's like the code should not have any understanding that it's testing against a mock. So that way, like you're keeping all that behavior, what you're testing against is how your code's reacting to whatever the mock's sending back. And it doesn't really know that it's actually interacting with a mock implementation below it.
So do you mark your database? Do you mark your user interface?
It depends. I mean, it's kind of whatever kind of makes sense within that instance of what you're trying to mock. So like it might be the database, it might be user interface. I wouldn't say like you should be using mocks all over the place, but I think it's probably best used for when you're kind of dealing with like weird and obscure scenarios or something like that. And I mean, technically also like a test container's instance is like also a mock in many ways. So
I I follow set of general criteria when I do mocking.
Mhm.
And more often than not has to do with, like you said, injecting error conditions that would be difficult to simulate.
Yeah.
And if the tests are low. Into the condition now. That's homeboy.
Yeah.
Basically, at the external layers. So if you're doing TCP/IP communication,
Mhm.
calling out the data, you have inputs that you need to simulate from the user interface. Yeah. Wherever the,
Yeah.
Those are areas where you lock something. Also that you weren't dealing with the real thing because otherwise the test would take too long to run on that.
Yeah, exactly. Yeah. So yeah, like I said, to exactly what the person you were saying is the audience member was saying was the saying it's like, mod can be good for when like maybe you're testing like a timeout or something like that. And there could be a good way with a mock to just send back an error, simulating that rather than actually having to wait the 30 seconds for an actual timeout to occur. Because once you start to get like a large automated test suite, then 30 seconds here, 30 seconds there, and all of a sudden it takes 8 hours for that automated test suite to run. So yeah, like I said, I think mocking can be very useful. Again, I think the issue is that people start running into issue where that some of the implementation of what the mock is somehow kind of creeping up into the code that it's being tested, or you're trying to too much simulate the actual underlying business behavior rather than just trying to do with some sort of specific condition or scenario. But yeah, but then to that, Makito is definitely, I think, like the best tool. I don't know if it's been superseded since, but like it's very straightforward, very easy to read. It gets back to that readable where it has like the given when then and all that stuff. So yeah.
Just as a final comment, mocking.
Mhm.
Again, this kind of gets back to the Chicago versus London style of mocks and what it's verifying.
Yeah.
And I think where mocks then start falling down, you scratch the essence. An incorrect test that's test and don't repeat anything.
Yeah.
Is when you use a style that verifies the mock itself. That you set up the mock to make a certain
Yeah.
number of calls, certain dependencies, and all you're verifying is did your code make those calls, not the result of the whole thing you're trying to test.
Exactly.
Result of something versus checking the internal implementation of it. If you check the internal implementation, your mocking is probably going to need to test and fail on exit factory.
Yeah, exactly. So yeah, to what the audience member was saying was saying like, sometimes you're kind of getting into where you're testing what the mock is doing itself. And also to that, like, I think that blog article is gone, but there's another one by Henri Tremblay. He actually runs the Montreal Jug. But so like I'm talking about mocking, but there's actually like 5 or 6 different types of mocks. There's like stub, there's like a fake, there's a spy, and so a double, and there's actual a mock itself. So I would definitely recommend like the different types of mocks Henri Tremblay, like, and it's spelled Henri, where he does kind of define each different one. And I think and there's like another article that did the same thing that I think also was like a very good narrative as to how they written it out. And it's like, oh, okay, that's why. Because like, and that was my issue before, is like sometimes I was writing like a mock that then tested what it was self was doing, and that, to your point of like, then eventually it's like I refactor it, then everything breaks and they're not testing anymore. And it's like, oh, okay, so this is a stub, I'm just doing that to fulfill a dependency. This is a whatever, a spy. I'm actually, making sure that like my code is sending the right value. So yeah, I think reading that can also help a lot. Yes.
Yeah, actually, there's a website of the same name, but it's some materials there.
Axiom test patterns. Axions. Oh, X units.
Yeah. I turned for the office, Martin Fowler. Or I have the book on my shelf and it's a big old thick thing.
Yeah.
Like this, but
Yeah.
it's got a lot of.
Yeah. So X unit test patterns. Yeah. X unit. So perfect. Yeah. So yeah. So oh, there we go. Actually, that's right. Right here. I actually have the link that I was talking about to not to the X unit test patterns, but to what I was talking about. Why is it not opening? Well, all the same, if you go to my presentation, what I was just talking about, the different types of mocks, I had a link to that blog article. So good on past me. I forgot it is that.
Just your slides.
Yeah, exactly. I'll just remember my slides. So performance testing. Performance testing is incredibly difficult. It's probably for a lot of developers not super important outside of certain areas. One area that's really nice. So recently, JDK flight recorder. I think this as is out of like JDK 17. It provides some ways to where you can actually within like your test. You can capture like the events that are occurring. You can maybe test to make sure it's like, okay, when we're calling like our database, like it needs to be completed within this time, or maybe how many times you're calling something, you could actually maybe capture that. So that can be kind of nice. It's probably not too important too often, but I was saying there's JFR unit for maybe handling that. There's also, yeah, JFR units.
A micrometer
Uh,
usually measures.
yeah, that is more. Yeah, it's micrometer though is more about production level. That gives you observability. And so this is more for within like automated testing.
Okay.
Yeah. Also, one, I think this is, yeah, one of the last, contract driven development. So oftentimes it can be very difficult. So like you have your back ends and then your front ends, and like you guys work at different paces because like maybe Billy's on vacation for 2 weeks, and so now back end's not going to make any progress, but front end, they're all available to do work. What you can do with contract-driven development is you can actually write out a test in a contract that can be actually then tested against, and you can have it either be simulating either the client or the server. So, like if you're on the client, you can have something that can test that simulates what the server is supposed to be doing, or vice versa. If you're on the server side. But by having either the client or server actually then develop against that contract, then hopefully you're writing out the contract well, and the other side's also testing against that, then it should all match up once it actually gets to production. If you're in the Spring world, there's a Spring Cloud contract where you can write it out. Like you can write it out. I do give examples in here. And it's now several years old, but it's just still principles remain where you can like write out either YAML, and I think they have like you can even write out in Java or Kotlin now, saying like, okay, if I send in this data, then it should return a 200 response. If I send this data, it's just get back a 400. Or if I send it, so you can fully like explain, and it's mostly for like API testing. I think they also now support messaging as well, or messages services. They can kind of write out that full thing, and it's not just the happy case. You can also write out the bad cases as well. Some additional tooling. Yeah. Oh, yeah. So yeah, I don't know. Hopefully most people know this. But yeah, there's Surefire. So if you're wanting to write your unit test, have those all be within the Surefire scope of your Maven test, and then have your integration test, which usually going to take a little bit longer to run. Put that all in your fail safe, so that way your unit tests hopefully they should all execute very quickly, and it can give you that very quick like, oh wait, yeah, you're completely wrong. And then you don't have to wait too long to get back that feedback. But then for your integration test, that can run in a separate cycle, so that way you're not running expensive, long-running integration tests only on code that you already know that's not going to be acceptable because of some other tests that are saying that that was going to fail from the integration testing. Yeah. So also to the earlier about when it comes to how code coverage can lie. So a really good way of verifying if like your tests are actually testing things properly is through mutation testing. And like the easiest tool to work with that is pit testing. And so what this does is like it goes into your code with like the bytecode, and it says like, okay, it like for like an if statement, it changes like equals to not equals, are less than to greater than, or like an iterator counter, it might change the value of it. And what it's testing for then is like if it goes through and makes this change, and then if none of your tests fail, that means that mutation survives, and it's telling you that you're not really testing this code that you think you are. So it can be very helpful. It's not like actually changing the code that's going into the GitHub repo or anything like that. It's just changing, like that, instance of it. But yeah, again, it's a really good way for validating behavior. It's a really simple tool to use. It does take quite a while, depending on how you're using it, to actually run. So you're not going to be running it every time. It'd be part of like your weekly or even monthly build, depending upon, how frequently you're changing your code. But very helpful. Oh yeah, I guess this is something AI generated test. It could be kind of good for you kind of have some code and now you can be like, okay, maybe might write me some tests that kind of test like the various inputs and outputs. Like I could see that being somewhat useful. Maybe I haven't really worked with it, but might be possible. There's a bunch of different options out there, and I think now it's also probably a lot of stuff that's already built into the various IDEs as well. But yeah, so again, this repo is now quite a few years old. I haven't really updated it since, but it does also give examples of using JUnit5, like a lot of the various features of JUnit5, at least as of it was back in like 2019. Which I think by then they had already kind of started to slow down on their updates to it because it kind of just reached maturity of it. But yeah, go through things like also Mockito, CertJ, and test containers. Also give an example of Spring Cloud Contract. Again, it's a pretty simple example, but it kind of gives you at least some of the different ideas. Then I also link to the JFR units tool that I mentioned earlier. But yeah, any other questions then, or vehement disagreements? Throwing raw fruits is it?
Property-based testing as opposed to example-based testing.
Yeah, I mean, I haven't really done much with property-based testing. Like I've heard of it, but again, like some of it's like I became a DevRel by the time I really was developing this presentation, and then it's like, well, I'm not really working on like coding in anger like I used to be anymore. So I haven't gotten to a point to where I really got to test out things like example-based testing versus property-based testing. I'm sure both have their use cases, and some of it could be to the point that other audience were saying was that, kind of falling in with whatever the culture is at whatever organization. If like, hey, we're all really big into property-based testing, then, maybe just kind of go with it versus saying like, no, we must do example-based testing. They probably both have their uses and benefits. So,
Any recommendations on how to test for thread sync?
yeah, that can always be very difficult and even more difficult now with like virtual threads. I haven't really gotten too much into that, so I can't think offhand like a good ways of handling that. So, new question that I need to give an answer to. Yeah.
Production, it will run for a year,
Mm-hmm.
and then all of a sudden, the processors in your multi-core system just happen to execute the threads in this exact
Weird
situation, and then it blows up.
Yeah.
You can't reproduce it.
Yeah, I think, and to that, I mean, that's also where like mocks can be useful, is to where you can simulate that specific behavior to say like, okay, if these threads get out of sync, or something like that, how can we make sure your code handles it? Yeah.
Runtime thread safety becomes the responsibility of the compiler because it checks your code before it allows you to compile. One of those patterns that it forces is resource acquisition as initialization, where or it might be like I might have acquisition and initialization switch behind the ground, but it should conform with known patterns with thread safety, which I guess like can become an afterthought if you're trying to get something out the door. You can use a language that is like secure, runs on the JVM, runs everywhere, and where thread safety might be either an afterthought or out of the scope of someone who writes code but doesn't decide what the features are going to be.
Yeah. Because, looking back at it, it almost seems like the Java language was when it was originally designed, thread safety was kind of a
Yeah, I mean, kind of back then that, yeah, and like, because also, you know, I mean, there were of course multi-threaded processors back then, but it wasn't nearly as common. Not like now. Yeah, now it's like, like the system I think has like 14 cores on it or something like that. Whereas like that was you have to, go to like a research lab to get something like that back in, 1990, in the early 90s when this is all being developed. Yeah. I mean, but I should say though, multi-threaded was designed from the very start, but I guess James Gosling and that crew just didn't. I mean, it's easy to say some of these things now, but not always knowing how things are going or having to understand. Yeah.
Java, and I'm like, what was James Gosling thinking when he wrote this or that?
Yeah.
Finalizer or something.
Yeah. So, oh man, I did recently talk. So Java, as you'll know very well, just had celebrated its 30th birthday back on May 23rd. And so the Java team, we did a 30th live stream, and I actually got to interview James Gosling, which was very intimidating. I mean, he's a very nice guy, but it's just like James Gosling, I'm just like an idiot. So I'm just like, but honestly,
What were you thinking when you were doing serialization? Which Josh Block goes on for chapters about what a security hole that is.
yeah, well, so
And the people knew at the time it was a security hole, and they did it anyway.
yeah, so to answer first about finalization, one of the things I asked them specifically about that was, and so at the time the need was is that like you needed a way to be able to clean up like certain like resources, like closing a database connection. And like at the time, like there wasn't try with resources or anything like that. So to making sure like a database connection was closed after it was used or whatever, finalizers was like a way of doing that. But then the problem with finalizers is that there's no guarantee on when garbage collection happens. Like you can say system.garbage collection or something but that just says to JVM like, hey, next opportunity you get, do it. But that could occur, in many cases it would occur that next millisecond, but depending on what's happening with the application, it may be a minute before garbage collection occurs or something. So then like you could run out of like database connection. So it was a case where I think it was written in about a single day or something like that. Yeah. And then so when it comes to serialization, oh man, yeah, going into serialization, like I remember I did like some videos on that, and yeah, there's like 11 different ways to actually get into that. But what's kind of funny is I was talking with like some JDK people. Let's see, who was it that actually wrote it? But I was just like joking how serialization was Java's like original sin. And I didn't realize I was talking to the person that actually implemented serialization. He's like, whoa, I implemented that. I'm like, I gotta go.
So what were you thinking? What were you thinking?
Yeah. He knows more about computer science and like here than I know in my entire body. So it's just like I couldn't even begin to conceptualize how to do serialization. So I can forgive if he didn't necessarily think through it all. But yeah, I guess to the point when it comes to security, like serialization was incredibly important though to the growth of Java. So it's like, yeah, there's definitely some serious security concerns about that, and it's also held back Java in some other ways, but also Java, we wouldn't maybe be celebrating its 30th anniversary as a still relevant language, without it. So, it would have been like so many other languages kind of written back in the 90s that just stayed in the 90s. Yeah, I mean, we're continually working as far as like fully getting rid of it. I mean, that's still a ways down the line just because there's a lot of organizations that still depend upon some of that behavior, but we're continually working to do it. There's things like serialization filters that can kind of also help reduce some of the security vulnerabilities caused by it. And then also things like records address a lot of the issues and how they're constructed, because like, you know, you can only construct like a record through its canonical constructor, and unlike with like a serial or normal class object. So we're continually working to remove it, but that backwards compatibility that, you know, we try to prioritize makes it difficult. Yeah, any other questions? Yes. John Rose is who wrote it.
Writes it to plain text, or because there's something exploitable about serialization.
So the problem with it is so like, okay, how do you create a new object? Like you want to create a new instance of an object. How would you do that in Java when you're writing it in code? Just not a true question. How would you do it though?
You call it constructor.
So exactly. But that is not how serialization creates a new instance of it. What it first does is just creates an instance of objects, and then it goes through and like adds all the fields in all like backwards, and then eventually it says like, oh, this is actually a person class, and then assigns it as a person class. So like it never actually calls the constructor for that class, which allows it gets to a lot of invariant stuff that could happen. So like if it, you know, like a name field, or, you know, some more exploitable thing like the database construction object, you know, has password, you could pass it in to have like some other values or some other connection string. And then that's a way an exploit can happen, because certain invariant checking is never done, just because the way it actually creates the object is completely backwards from like how it's actually supposed to be created.
That's just dependency injection, right? Everything's backwards.
Yeah, but then there's ways you can maybe actually send like, you know, a serialization object over the wire. It's not like quite like normal dependency injection, because you can just send something over the wire just as like a normal transaction or whatever that can then like mess with the system. So that's way things like serialization filters can limit like how objects are constructed, or specific classes how they're constructed, to prevent some of that stuff from happening. But yeah, if you actually learn how like Java serialization works, your mind will explode, because it's just like there is a whole lot of there's like 7 or 11 or different like properties of like a class that aren't really in the official, or aren't in the official like API for a class. That is how like a serialization works to like serialize and deserialize a class. And it's just kind of like but it's just necessary, because like a Java, at least kind of back then, it's like, well, we wouldn't necessarily know like what this serialization file is, what class is it. Okay, it doesn't find it out until the end. So yeah.
In general, it's just a bad idea to be sending executable code.
Yeah.
On the internet, because that's how you inject a virus.
Yeah.
It just goes, it's just going to execute this.
Yeah.
Won't tell them what it is.
Let's go down to demand as part of the rest of the street.
Yeah. Yeah.
The point is what you should be sending across as a message.
Mm-hmm.
It's a defined format, and you can verify that the message meets the format.
Yeah.
And then you've got a message, but you're not sending something that you're just going to blindly run.
Yeah. Yeah. Hopefully not. But yeah.
You know what it is.
Yeah. Former colleague, because when we worked together at IBM for a bit, Steve Poole, he had some like really good, funny but terrifying presentations about like all he could exploit with like serialization. So yeah, like Steve Poole, Poole, normal way of spelling Steve with a V. But you can like Steve Poole serialization fine or whatever. Like you can watch that presentation if you want to kind of get terrified about the security vulnerabilities in serialization.
I think he came to that Nexus, so I
Mhm.
spent quite a bit of time talking to him.
Yeah.
Now, what,
Yeah.
come on.
Yeah.
I think they actually had comp sci professors look at it, and the comp sci professors were saying, no, they don't do it, and they just flat out did not listen.
Yeah. Yeah. Like I was in elementary school, so I can't. Yeah. So, still not really qualified to really get into some of this. Yeah.
So, okay, so I can't let a talk about testing go by without mentioning what Edgar Dijkstra really said about testing.
Oh, okay.
Testing can prove the presence of bugs.
Yeah.
But it cannot prove the absence of bugs.
Yes, which is why you still need to do manual testing. That is an exploratory.
Won't do it because
Yeah, I know.
the trouble
Yeah.
is, software is so complicated that the
Mhm.
number of test data that you could have grows just exponential. And it would take even the fastest supercomputer
Yeah.
more time than the universe has been in existence to test every cotton picking.
Yeah, and that's why I also say it's like, I mean, you're right. There's no way to prove your code is, is well or bug free. Yeah. So
You actually write them at proof.
yeah, and that's just often not necessary for organization. Even the most critical software is probably not necessary. So how many tests do you write? Whatever gives it a confidence just to say, I commit my code, and between me and going to production is only the automated test suite for testing for correctness, whatever your organization defines it as, and to make sure that they're catching everything, you do still need to have some level of exploratory testing happening, by people that kind of understand the business needs to say like, okay, like, are they actually testing this? If I did this, I put these emojis into a person's name, is it going to catch that? That's so, yeah.
I'm thinking here like the cryptography,
Mhm.
That we depend on to keep our messages safe and
Yeah.
try to keep the hackers out. There's just too many combinations there, and we
Yeah.
kind of need to write it through.
Yeah, and like I said, I mean, then I get like, so just to your point, like you're absolutely right, and that you just have to measure, what makes sense, because like, yeah, you can't just say we're gonna add a line of code and now we're gonna spend 100 hours writing tests for it. So you have to kind of balance. Yeah.
That you can apply test design, including identification of code classes and boundary values.
Yeah.
That way, with code classes, the whole idea is you don't want to test every possible value.
Mhm.
Group them based on values that should behave the same way.
Yeah.
And you can choose anything from that set of boundary equivalence class values for your tests, or anything random.
And this is where property-based testing can actually get into. Are you maintaining the equivalency?
Mhm.
And then you let the computer come up with the testing data
Mhm.
and see if the computer can let the computer find the example data.
Yeah.
That makes the property fair.
Yeah. And then also, that is where did I have that? Or is that additional? Like mutation testing can do is to make sure, because like it can again go in and change like certain values of like, what if we put in 1,000,000 into this, final constant field instead of the usual value of 10, does something catch that to say like, whoa, this is way out of bounds or something? That could also be a way of trying to catch bugs you just don't know about as well. So yeah, like I said, and again, it all kind of comes back to what makes sense for your organization, because ultimately the vast majority of organizations aren't trying for mathematical proofs that the code is bug free, but rather making it to where it's at a reasonable level. So they're not going to suffer reputational harm. They're not going to suffer financial loss, something like that. Once you kind of get to some of that level of like, okay, we're confident, we're not going to, have some major issue, then you're kind of good. And like I said, it's going to vary from organization to organization. There's no industry standard for that. So that's kind of why.
So the Chinese break in.
Yeah. Well, yes. Yeah. So, all right. Yeah, I think we're at about 8 o'clock or after 8 o'clock. So yeah. Any final questions or?
I actually looked at that, and there was a paper on that was written by none other than Alan Turing himself
Yeah.
on how to verify the correctness of code. And he actually did a mathematical proof of some routines.
Yeah.
Published a paper.
Nice. Cool. Well, thank you everyone for coming. Thank you again, Bruce, and to everyone on the St. Louis, or I guess, do you guys go by St. Louis Jug or Gateway? Okay. So St. Louis Jug, thank you again for inviting me. And so hope to be here again sometime.
Well,
Sometime soon.
thank you very much.
Yep.
Okay, I think we can turn the recording